Hello and welcome to Study IQ. I am your friend Rahul Saigaonker. Before I begin today's discussion, there is a small request from my side to all the viewers. If you have not subscribed to our channel, please subscribe to StudyIQ IAS English channel. Like the videos and share the videos so that our channel reaches to more and more number of people who are in need of it. Help us grow. Right, let's begin our interaction today for NCERT Science series. You already know we are discussing class 9 NCERT and we are doing a chapter by chapter analysis. In our previous two chapters, the focus area was matter. I hope you have seen the videos. We discussed that matter, it comprises of tiny particles called atoms. We also discussed the characteristics, certain characteristics. In the subsequent chapter, we discussed about pure substances, elements and compounds. Impure substances, that is mixtures, heterogeneous mixture, homogeneous mixture, solutions, colloids, suspension, etc. All these things. And in the next two chapters, that means today's discussion and the next discussion, the next chapter, our focus would be on understanding atom. And you will see that we are heading into the territory of chemistry. So we'll understand atoms and molecule structure of atoms more and more to focus on chemical reactions or chemical composition. But there is a small cautionary note here. We are not going to focus on numericals. We are not going to focus on balancing a reaction, right? Not on the technical aspects. Our attention would be more on understanding the concept to gain conceptual clarity from the point of view of UPSC Civil Services examination. So let's begin chapter 3, atoms and molecules. But before that, I hope you've heard about UPSC's or Study IQ's UPSC program, that is Prelims to Interview Initiative. This is the most comprehensive program, entire coaching and guidance in English. The first batch in English is starting from 19th of June. We will be hand-holding you from prelims to your interview. If you clear your prelims, then you will be called for a mains residential program, where the entire expenses would be carried out by Study IQ. What you will do is simply study and answer writing practice. We will be refining your answer writing. It is more like the Guru Shishya Parampara or the Gurukul concept. So you will be coming to the Gurukul and all the expenses would be taken care of by Study IQ. All right. So do enroll for this program. It is priced at a very affordable range. If you want discounts on this also, you can use my code Rahul Live. I'll see you in the class. Right, let's begin our discussion. As I told you, today's interaction is about atoms and molecules. We already established matter comprises of tiny particles called atoms. We also saw some characteristics. Right from time immemorial, that means from ancient time, people are trying to explain what the matter is composed of, what the universe is composed of. We discussed about Indian philosophy. Indian philosophers, Indian thinkers, they gave a concept of Panch Tattva. Our body or any matter in the universe, it is composed of Panch Tattva. So, did we discuss concept of atom also? Yes. Now, we are going to connect some knowledge from here, science knowledge, to history. In your history, you must have discussed about 6 schools of Indian philosophy, right? 6 schools. What are those? There is Nyaya, there is Sankhya, there is Yoga by Patanjali, then there is Mimamsa, Purva Mimamsa and Uttar Mimamsa. Uttar Mimamsa is nothing but the Vedanta philosophy. And then there is a 6th school called Vaisheshika school. Have you heard of this? Vaisheshika school, which was developed by Maharishi Kannad Kashyap. This Vaisheshika school is nothing but the theory of atom. Maharishi Kannad Kashyap, right? He said that any matter or any padharth, it can be divided into tiny particles, and the smallest particle which cannot be further subdivided, that would be Paramanu. This Paramanu is nothing but atom. Paramanu. Paramanu means atom. The same explanation was given by the counterparts from Greece, more or less in the same era or same time, by Democritus and Leucippus. Democritus and Leucippus also said that matter can be divided into subparticles, and at one point of time you will reach to one particle which cannot be further subdivided, and that is nothing but your atom. Of course, it's invisible. But in the modern era, with the development of science and technology, new kind of equipment, different kind of testing methodology, by 18th century, scientists recognize that there is a difference between something called as elements and compounds. They established that, of course, the smallest unit is something called as atom, and many atoms, pure substances, we discussed what are elements. Elements are atoms of pure substances. So more number of atoms, when they join, they form elements. And different elements, they can react and form some sort of a compound having different characteristics. We discussed that difference between mixture and a compound. In a compound, the elements can combine, bringing or giving completely new properties. So chemists and other experts started to experiment, and finally Antoine L. Lavoisier, he laid the foundation for chemical sciences by establishing some important laws for chemical combination. He said when two elements X and Y, when they combine, leading to formation of a compound or any other chemical structure, they follow certain laws, rules and regulations. What are those laws? The first law of conservation of mass. Antoine highlighted that any chemical reaction or any chemical reaction or chemical compound which is formed, it follows the law of conservation of mass. What is this? It says mass can neither be created nor be destroyed in a chemical reaction. That means the reactants would give you some products and byproducts, and the mass of both the sides, it has to be same. You can see here law of conservation of mass. Say when methane combines with oxygen, the reactants are 80 grams, and the final products, carbon dioxide and water, that would be 80 grams. This is the basic idea of law of conservation of mass. Mass can neither be created nor destroyed. Whatever reactants you use, they will be transformed into final products plus the byproducts. Apart from this, there is one more law of definite proportions or law of constant composition. This is also called as the Proust's law. Now, Proust's law is extremely important to understand chemical reactions or chemical composition. Now, let me give you a very simple expression of this. What this says is any chemical compound, it is going to have definite composition no matter what, no matter how you prepare it, no matter from which source it comes. If it is a chemical compound having one particular structure or one particular composition, it will have definite proportions in it. For example, CO2. The classic example would be carbon dioxide, right? CO2. Now, you know, carbon dioxide is released by us. Like we basically breathe in, we take air, we use the oxygen, we release high carbon dioxide. So carbon dioxide, wherever it comes from humans, it comes from, say, agricultural sources, or it comes from industrial sources, it comes from the exhaust, from the IC engines exhaust. From wherever it comes, it would be the same composition. It will have definite proportion, CO2. That's it. All right. That means if you take 1 gram of CO2, if you take 16 gram of CO2, if you take 1000 grams of CO2 also, there would be definite proportions for carbon, oxygen in the same composition itself. So two laws were established. But the next question was that, how do I prove these? How do I prove these? Now, scientists were now thinking about how exactly, or how in an appropriate way we can explain these laws. Then came British chemist John Dalton. Right? Now, John Dalton, he gave certain rules and regulations regarding these laws. John Dalton, a British scientist from 1700s. What he did was he gave certain rules and regulations where he said all the matter, it is basically composed of tiny particles called atoms. These atoms, they participate in the chemical reaction. Atoms are the last item. We cannot divide any atom into further subatoms. That means atoms are indivisible. They cannot be created or they cannot be destroyed. They are already in existence. So atoms are something which give any element its identity, its mass and its chemical properties. So it is because of the atoms. Atoms has mass. Atoms give certain chemical characteristic to the elements or the compounds. And atoms of different elements, they have different masses and different chemical properties. And he also said atoms can combine in the ratio. Atoms can combine a ratio of small whole numbers to form compounds. And finally, the relative number and kinds of atoms are always constant in a given compound. So these are the laws which are given by Dalton, which laid the foundation for entire chemistry or chemical understanding, right? Chemical reactions. So what is an atom now? An atom is the basic unit of any matter which cannot be further divided. It is the smallest entity which of course we cannot see through naked eye. So what is the size of it? It's extremely small. It's in the order of 10 to the power of minus 9 or even 10 to the power of minus 10 meters. All right. So you need to get that atoms are very small. They're smaller than anything that you can imagine. These constituents of atom would be much smaller: protons, neutrons, electrons. We'll talk about that in a subsequent discussion. But just look at the atom of different elements. For example, hydrogen. An atom of hydrogen is approximately the size of 10 to the power of minus 10, and this 10 to the power of minus 10 is called as angstrom. You must have heard of this. A molecule of water, that is H2O molecule, it is of the order of 10 to the power of minus 9 meters. It is in the range of nanometers. A simple apple that we eat, it is in the range of about 10 to the power of minus 1 meters, right? It basically in centimeters. All right. So imagine the size of an atom, extremely small. And what Dalton did was he wanted to understand different atoms and elements. What he said, what atoms are the smallest entities, they take part in the reaction, and it is because of the atoms that every element has mass, and every element has certain chemical characteristics. So what he wanted was he wanted to give a connotation or distinguish one element from another element. So what he did initially was he proposed some of the symbols. Initially, some symbols like hydrogen was denoted something like this. That means 0 and a dot would be hydrogen atom. Carbon, oxygen, all these things were given by Dalton. But it's understandable. Now we already know in the periodic table there are more than 110 elements, and imagine such small images like this to define those elements. It would have been very tough, right? Then came the IUPAC, that is International Union for Pure and Applied Chemistry. Now what happened was IUPAC, or in short we call it as IUPAC, it's an organization which names the elements, compounds, etc. It basically brings out rules and regulations which are connected to chemistry. So what they did was they came up with certain strategy for naming different elements. Now some of the elements, they were basically named in English. For example, after whatever you explain, say if something is sodium, its Latin name, sodium's Latin name is natrium. So they took the first 2 letters of it. Many in English, for example, chlorine. In chlorine, they took first 2 letters of chlorine. See, first, not 2, the first and third letter. For zinc, they took first and third letter. So they made a combination of letter or first 2 letters or their Latin names. Many times you must have seen some elements, wherever they are discovered, they come from that. Some of the synthetically discovered elements or synthetically produced elements, they have been given the name of the renowned scientists. Right? There is Einsteinium, there is fermium, etc. You must have known synthetic elements also. So the naming is done in such a way. For example, copper, the name of copper is taken from Cyprus. Gold, the name of gold is taken from English word. All right. So it is named from Orium EU. So such nomenclature has come up, and we have developed a periodic table. You already know, and these are some of the examples of elements and their nomenclature. Meaning, now when I say aluminium, aluminium is now denoted by a symbol called as Al. Aluminium is an element which has a mass, which has a definite atomic mass, which has a definite chemical characteristic, and this aluminium is made up of aluminium atoms. All right. So aluminium, Al, argon is Ar, barium, Ba. So this is a list of some of the important elements. There is no need to mug up per se, but if you're preparing for JEE or say any other competitive exam, probably such symbols might be asked, but in UPSC this is not important for us. But nonetheless, some of the important elements and their connotation. So if there is a statement, for instance, the elements and their nomenclature, if I can create a question on this, all the elements in the periodic table have been given a name based on their first or the second letter. That statement would be wrong. Nothing like that. Many times, for example, if you see silver, if you see gold, English name Orium, you get EU. Then if you get silver is denoted through AG, right? So name silver but AG, sometimes it can be different. So nomenclature is decided by IUPAC, IUPAC, International Union for Pure and Applied Chemistry. Now, next question is, what is atomic mass? See, atomic mass, this was developed to explain the concept of definite proportions, the law of definite proportions. Now, Dalton said that every element, it has its own characteristic atomic mass. Characteristic atomic mass. Now, he said, if I take aluminum, aluminum has certain characteristic atomic mass. Carbon has certain characteristic atomic mass. Oxygen has some atomic mass. Now, for defining any kind of unit or any kind of I would say a measuring parameter, what we need is a reference. We need a reference, right? For example, I have weights now. If I go to market, I have to buy something. I have to buy 1 kg of onion. So 1 kg has to be defined. 1 kg has to be defined. It would be defined by the organization connected with the standards. Say, for example, if I have to buy pieces, if I cut this watermelon into different pieces, now what I want is, I want watermelon which is equivalent to two pieces of another fruit. So this is how I define it. I need some sort of standard, correct? So scientists began to define every element based on its atomic mass, and we have created a periodic table. Initially a standard was needed. So what standard did they take? They took the reference of oxygen. Initially, they established that atomic mass unit of naturally occurring oxygen was 1/16 of the mass of that particular atom. It was defined, and then with reference to oxygen, the other elements were defined. But in 1961, under IUPAC itself, under the other organizations, it was accepted that the reference unit for any atomic mass unit would be carbon-12 isotope. So please remember, from exam perspective, when I say hydrogen has an atomic mass of 1, hydrogen has atomic mass of 1, what does that mean? It is in reference to carbon-12 isotope. What is an isotope? We'll understand in our subsequent discussions for sure. Now, if I say oxygen has an atomic mass of 16, that means it is again in reference to carbon-12 isotope. So these are some of the reference atomic masses of few elements. Now you already know, we'll discuss about periodic table, etc. So for any element, say if I talk about hydrogen, I denote it as 1H1. That means this would be the atomic number, this would be the atomic mass. We'll discuss atomic number, atomic mass, different isotopes in our subsequent discussions for sure. But we are talking here about atomic mass. Carbon. Now, carbon's atomic number is 6, but its atomic mass is 12. This is the reference, carbon-12 isotope. And with reference to carbon-12 isotope, all the other elements have been defined. Their atomic masses have been defined, and a periodic table has been created. Clear? Do not forget about this. Next, different elements can combine, or different atoms can combine to form molecule. Now, what can be a molecule? A molecule is generally a group of 2 or more atoms that are chemically bonded together, or tightly held by some sort of an attractive force. It can be an ionic bond, it can be a covalent bond, it can be different kinds of bonds. They are held together by bond, and every molecule, it can be defined as a smallest particle of an element, or it can be a smallest part of a compound as well. So please remember, atoms, when many atoms come together, they lead to formation of elements. Now, some elements can be molecule, and some molecules can be compound also. Please try to understand this. Whenever I define a molecule can be a combination or a smallest particle of an element, or it can also be a smallest particle of a compound. I'm quite sure you're thinking, sir, I want to understand more. I'm not getting that clarity. Now let me explain through this. A molecule can consist of same type of atoms. A molecule can consist of different type of atoms as well. Molecule can be of elements. Basically, when I say element, oxygen, I use O2 gas. That means this molecule has 2 atoms of oxygen. Chlorine gas, I denote it as Cl2. That means Same atoms, they comprise a molecule. Hydrogen, for example, hydrogen gas, H2 gas, we say H2 is a gas. Now H2 is a molecule comprising of two atoms of hydrogen. Similarly, molecule can also lead to formation of a compound. It can also lead to formation of compound. For example, classic H2O. Now H2O is a compound. H2O is a molecule also, right? Molecules of a compound. H2O, molecule which leads to a compound, right? Molecules of compound or molecules of element. I hope it's clear now. All right. So please remember, whenever I say molecules of elements generally are of same atoms. It can be diatomic, triatomic, monoatomic also, monoatomic, diatomic, triatomic, etc. It can also comprise of different kinds of atoms which lead to molecules of compounds. They're held together by different bonds. All right. So let me just again give you some differentiating pointers. Molecule of an element, it is a combination of two or more atoms of same type, but in a compound it is different type. Molecule of element has atoms of exactly one chemical element. Here it can be two or more different elements. Remember, in a molecule of element, they are held together normally by a covalent bond, but a molecule of compound, it can be covalent or any other kind of ionic chemical bond. Examples are many that I have already given to you. All right. Apart from this, whenever a molecule of element or a molecule of compound, they dissociate, they lead to creation of ions. This is where the reaction comes into picture. Now, whenever we talk about any element or any atom, an atom comprises of different structure. We'll talk about structure, where we say nucleus, it comprises of protons and neutrons, and there is a configuration, or there is an electron cloud around it. And the configuration of electrons of this atom, it describes or it defines its chemical properties also. And we talk about something called as valency. Now, valency means how quickly an atom can accept an electron or lose an electron. Now, valency, to be described in very simple terms, valence electrons or valency of any particular atom can be considered as hand. Say for example, we have two hands, right? So human valency 2. Take example of an octopus. An octopus has 8 hands or 8 limbs basically. So the question here is, how many other atoms or how many other constituents, entities can I hold? I can hold 2, but the same for octopus is 8, right? And an octopus can hold 4 persons basically. So that is how we define the valency of one particular atom, and this valency defines the chemical reactivity or chemical composition of that element. And I told you, whenever they dissociate, they form ions. So ions can be positive or ions can be negative, depending on the valency or the valence electron position of that atom or element. All right. So positive ions are called cations, negative ions are called anions. And through this itself, we devise chemical formulae. Now you must wonder, you must think, sir, in your examples, you have told about NaCl, right? You have told about NaCl. This is sodium chloride. Sir, why don't I call it chloride sodium? Right? For example, I have water. I write it as H2O. Have you ever thought, sir, why is this not OH2? Why is it not like this? Is there any difference between this and this? Technically, no, because the chemical composition is same. Is there any difference between NaCl and ClNa? No. Then the question is, why exactly we write something as NaCl only, something as HCl only, H2SO4 only? Because according to IUPAC and other chemistry organizations, they have created some rules of chemical formulae. Whenever there is an ionic species, the sum of charges of the ions must be equal to 0. Now you can see here, when I write NaCl, Na plus is a cation, Na plus, it has a valency of 1. So Na plus, when it joins Cl minus, because chlorine has again negative 1 valency, that means Na plus Cl, they are going to balance each other. That is why NaCl, meaning in an ionic species, the sum of charges is equal. Same in a covalent species, for example, H2O. Now, when you talk about H2O is a molecule. Now, hydrogen has valency of 1, H plus, but oxygen has 2 minus. That is why when you add these two, you will get H2O. Similarly, in ionic species, always the cation is written first. That is why it's NaCl, not ClNa. Same applies in a metallic kind of combination. The metal is written first. For example, say I write Na2CO3, right? Sodium carbonate. Na2CO3. I write Na2 first, CO3 later, right? First connected to metal. Apart from that, the number of atoms of each element or ion in the formula is written to the right of symbol as a subscript. You can see here Na2. It's always subscript. It's not equal. Please remember, in terms of nomenclature, when you are writing answers also, first letter should be capital. The second letter, if it is a two-letter element, second letter should be small, and the number should be much smaller than that. It should be subscript. Na2, it should be C, it should be O, because C and O are different elements, and 3 should be again subscript. That is the right way of writing, or right way of nomenclature writing. And again, if a compound contains more than one polyatomic ion, each ion is enclosed in bracket. So many a times you must have seen that some compound, say for example, some kind of ore, if it has a lot of water molecules, then we do write H2O in a bracket, and we write some sort of a number to explain it. Correct? For instance, say I can write some sort of a compound like NaOH2. I write NaOH2, NaOH3, something like this. Okay, it might not be chemically correct, but I'm just giving you certain examples. All right, I hope it's clear. Right, next, you can see some examples here. When I write HCl, H plus 1, Cl minus 1, so they both balance, and I write HCl, hydrochloric acid. Same applies here. Now H2S, hydrogen sulfide gas. Now I write hydrogen. Why I need 2? Because sulfur has a valency of 2 minus. That is why hydrogen sulfide gas, H2S, is written. Similarly, I write Al2O3 because I want to balance these two. See, Al2O3. Always metal first, and they have to be balanced. Our primary focus is not about balancing, but I want you to know these things for sure. Okay, how do you write a chemical form, right? Now, apart from this, there is one more unit in chemistry which has been developed. You all know there are 7 fundamental SI units, and one of them is mole. Now, please remember, what is this mole and why have you brought this in chemistry? See, I was very confused when I was reading this in my school and in my college. I used to think that why they have created mole. I can simply take in chemistry, okay, in the lab, we take, say I take 10 grams of chemical 1, 10 grams of chemical 2, I mix both of them, right? It's easy, right? But then again, you need to understand in chemistry, when we talk about atoms and molecules, they are extremely small. Means we cannot measure them physically. Measuring them atom by atom, molecule by molecule, it would be impossible. Yes, I can use a thing in terms of grams, which is much easier. But when I take a composition, say for example, I want some molecules of, say, carbon dioxide to react with some exact number of molecules of, say, water, so that I want weak carbonic acid, H2CO3. How do I decide that? Taking weight, say for example, taking weight in terms of gram, it does not make exact sense, because the number of molecules cannot be assessed or cannot be calculated. So what have we done? We have created a new SI unit called as mole. Now it is written as, or it is denoted as MOL, mole, right? Mole. So a molecular mass of a substance is sum of the atomic masses of all the atoms in the molecule, and it is expressed as atomic mass unit. And whenever we take an atomic mass unit, we have created a unit where we say one atomic mass unit of any molecule, of any compound, it is going to have standard number of its constituents, standard number of atoms, standard number of molecules in it. And that is defined by something called as Avogadro's number. So please remember, a mole is a unit in any chemical reaction. This mole, it indicates the number of atoms or the number of molecules. Remember, number of atoms or number of molecules taking part in the reaction. So it is one of the SI unit. It's equal to 6.0221 into 10 to the power of 23. Now this has been given by the scientist. There is no need to mug up the number also, but I want you to know that Avogadro's number is basically the number of atoms or the number of molecules in 1 mole of that substance. All right. Again, please remember, Avogadro's number was not given by Avogadro himself. Avogadro basically gave Avogadro's law. It is connected to the volume of the gases. Now, based on his hypothesis, based on his theory, many chemists, they came up with this number. In fact, it was Jean-Pierre Perrin who gave the idea, or who gave the nomenclature of Avogadro's number. And he said that 1 mole of any substance, it is going to contain this number of atoms or this number of molecules, which help us in terms of understanding the chemical reactions. All right, let me just explain. Many times I used to get confused by this, but to put it in very simple language, let me take example of CO2, carbon dioxide. Now when I say carbon dioxide, I already know that the atomic mass of carbon, this is 12. The atomic mass of oxygen, this is 16, correct? But you can see in carbon dioxide, there are 2 atoms of oxygen. That means there are 2 atoms of oxygen. So totally, when I add all these 3, I say carbon dioxide has a molecular mass of how much? It has a molecular mass of 44. So 1 molecule of carbon dioxide, it is 44 gram. All right. Now this 44 gram, it becomes 1 mole of CO2. This is the unit that we have created. And please remember, when I say 1 mole of or 1 mole of CO2, it is equal to 44 grams of carbon dioxide, and it is also equal to Avogadro's number 6.022 into 10 to the power of 23 molecules of CO2. I hope it's clear now, right? The 1 mole of any particular compound or any particular molecule is equal to its molecular mass, and it basically defines that these number of molecules are present in 44 gram. These molecules are present in 1 mole of carbon dioxide. It's a very simple kind of example to understand it further. Although it's a little confusing. I used to think this, why so much of hassle? Why so much of hassle? But as you try to understand in chemistry, many a times in chemical reactions, I want to understand the nature of chemical reaction, the dynamics of chemical reaction, chemical kinetics, chemical dynamics, the chemical kinematics. Then I do need Avogadro's number, which will help or which will ease my calculation and understanding. But again, from UPSC civil services perspective, you don't need too much of calculation, too much of numericals. In fact, we do not focus on that at all. But remember, Avogadro's number was not given by Avogadro, it was given by Jean-Pierre Perrin. All right, and Avogadro's number is this. So 1 mole of any particular compound, it is equal to the molecular mass of that compound, and that molecular mass is going to contain this number of molecules or this number of atoms. All right. Now, if you are getting still confused, as I gave an example of CO2. Now, if I just change this CO2 to anything else, say let us take a molecule of elements. Say for instance, say nitrogen. Let's take nitrogen gas, N2. Right? We know what is the molecular mass of nitrogen, 14. But there are in this particular nitrogen gas, there are 2 atoms of nitrogen, so it makes it 28. So 28 grams of nitrogen gas is equal to 1 mole of it. And remember, this contains how many molecules? Again, the same number of molecules. All right, that's the beauty of chemistry. So this is the last topic of discussion. I'm quite sure it has been a little bit of head scratcher. That is why we do not focus too much on chemistry in terms of UPSC civil service examination. As I told you, we are not going to discuss more about balancing the reaction or numericals, etc. Just the basic gist of it, right? So that's it in this particular discussion. If you have liked this discussion, you can always follow me on this particular ID at the rate Rahul Sai 222. And do not forget to subscribe, like, and share the video. Thank you for watching this. Jai Hind.